Okay, the children are fed. They are happily occupying themselves, and I have a few precious minutes to work on art. Our goal in this series is to create things that look like this very, very pretty fern looking thing, or I don't know what it is, but we've been working on the process of getting this system up and running, and where we're up to is we have a system, which I'm calling Ash Tree, that does things like this. So if I source the script, it creates something that's growing in a line. That's one part of what goes into our functions, right? Into our system. Let me look at, this system has a lot of things that are kind of growing upwards in lines, so that's kind of a good start, but we don't have any of the branching going on, so we're going to try and work on that. Before I get to that part of it, what I'm going to do is something that I find really useful when developing new systems, and especially when building packages, but it's true for other projects as well, is to start trying to kind of clean up my scripts a bit. So where we're at right now is everything is still just growing and growing and growing and growing and growing and growing and growing, right? When we wrote Scroll, we ended up with one long script that I think was about 130 lines of code, and we're headed in that direction again. It would be nice to kind of not have everything just go long, 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 long. It would be nice to be able to have it, branch out a little bit. So why don't we have our code branch out as well? The way that I'm going to do that is to pull out some of these functions and include them in different scripts. So let's say what I want to do is I will create a new R script, and let's say I don't think my user is particularly interested in, all of these helper functions, right? If you really, really want to understand the code at a low level, it matters that you look at these functions, but really they're not the best first thing for a new user to encounter when they are coming to use your Ash Tree system. So what I'm going to do is I'm just going to cut and paste. So I'm going to take all of those helper functions out of this Ash Tree script. I'm going to put them over here in this other new script. And so now the only thing that's in this script are just the helper functions. So what I would now do is kind of go, okay, let's save that, and I'm going to call it helpers. There's one I'd started creating earlier. Let's overwrite it and go, okay, yes, we'll overwrite that. Okay, so now we have this helpers script, which all it will do when we run it is create all of the helper functions that we need. To kind of illustrate what that will do, right, I will go over here. I'll clear my global environment, and what I'll do is source this script. Right? If I click source, it doesn't produce anything, like it doesn't generate the tree, it's just creating the functions that we will use elsewhere. So going back over to our script for Ash Tree, what we might want to do is something very, very similar in spirit to library tidyverse, in the same way that we had to load the packages of tidyverse before we could use them. If we want to be able to use our helpers, which are now over here in this script, if we want to be able to call them or use them within our Ash Tree system, we need this script to be sourced before our code goes on to do all of this other stuff. So what we can do is recognize that source, although we've been throughout my class up to this point, we've been treating source as though it were, just this button that we can press. It's actually an R function, right? You can see it right there in the console. So what we'll do is first, because I've been trying to encourage people to use the here package so that all of the files that you want to use are specified. Sorry, where's my... There it is. It's over here. Okay. Relative to the location of the rproj file. So what I'll do is add one more line here that goes library here. Okay. And then what I'll do is say source. And let's have a look at this. So file equals here. And then it's just going to be helpers. .r. I've put this in the same part of the code that where I've been using library to load packages, because the kind of behavior we're going for here is really quite similar. It's not the same. Loading a package is not quite the same thing as sourcing a script, but they're not entirely different. So for the purposes of this project, let's keep all of that stuff in the setup part. So I'll save that. And I will restart my R session again. Okay, like this. And I have to wait a second, I think. There we go. Now we're ready to go. And so what I'll now do is I'll go source I'll just close helpers for now. Just this. So I'm going to source the ash tree script. And what I want to illustrate is go, okay, it still does exactly what we wanted it to. So what it's done is it's loaded tidyverse. It's loaded the here package just so that I can manage my files in a reproducible way. I've sourced all the helper functions, and then I've gone straight to defining my worker functions. Cool. Sort of suggests that what I could do is create another new script and put all the worker functions in that. So that's what I'm going to do next. So let's grab all of the worker functions. Okay, we go down there. We go ship like this. We go cut. Pop over here. Go paste over there. We save this one and I will call it workers.r. Okay, back over here under ash tree. What I now want to do is go source file equals here workers.r. And now what we've really got is our code in just two sections. So our ash tree, I'll just save this by pressing the wrong buttons as I always do. There we go. The ash tree function now just has the bare minimum of stuff in it. It's got here's all the stuff you have to do to set up, to get it ready to go. And then we've got this thing, this process that is going to draw our tree. This is kind of nice. Right now we've just got 25 lines of code, and all of the stuff that most of your users would probably not want to look at is tucked away in a different file. Keeping things in separate files is sort of helpful for project management and organization. Okay, so that's a handy... Why do I keep pressing the wrong buttons? That is a handy handy thing for project organization. Now that we've branched our code into separate scripts, can we do something about the fact that our tree is not in fact branching? To do that, I'm going to cut back to my slides now, which we have neglected for so terribly long, and go over here. It is time to talk a little bit about the structure of our code, right? We've been, over time, we've been defining a bunch of functions as we go. So here's a whole bunch of worker functions, all of our adjust functions, our helper functions, sorry. There's the adjust thing, there's the radians thing, and we've got all of these worker functions over here. And some of the functions call other functions, right? So the way that I think about this is that we've got over here our helpers, like, yay, they want to help, but they're not, like, they're just little things. They sit there in the background doing some of the work for us. Then you've got the growing functions or the worker functions that are actually the core of, they're doing the real, like, they're the design of your system, right? And I like to keep those two in separate places. And you're going, yay, we're happy, we're making things. So the user is typically going to think about workhorse functions, or probably even just the stuff that's available in the top level function, like in the ashtree.r function. This kind of separation is helpful. And so now we have this system that we can start thinking about in a fairly, I hope, helpful and straightforward way. So we've got a process that at the moment is unfolding like this. We grow the sapling, we then grow something from the sapling, and in doing so, what we're doing is we're moving the tip of our growing tree forward as we go. So we've gone grow sapling, then we've called the grow from function, and it's gone, hey, we've moved the tip forward over here. When we call that, in the background, all of our helper functions are making this a little bit easier for us, but they've been swept aside, so we don't actually have to look at them all the time. And that makes it so much easier for us to write our code and read our code. So we do it again. Again, the worker functions, the helper functions just sit there in the background helping us out. We keep moving our tips forward and so on. And now we're at the point of needing to do that thing. Before we get to that point, what we need to do is have a little chat about iteration. Our process as it's unfolded looks kind of like this. We've gone grow sapling. What we really want to do before instead of growing one time, what we want it to do is split and grow multiple times. And so what we really want is a new function called grow, we'll call it growmulti. And inside it, it's going to call grow from, let's say, 3 times. Each of those would, of course, themselves call the helper functions over here. But all of that stuff is, again, I keep trying to say this and stress this, all of that stuff gets to be put in the background. Functions give you this blessing of abstraction. You don't have to think in terms of all of the low-level operations like adjust x, adjust y. You can just now think about in terms of a grow from operation. So a grow multi operation should consist of 3 grow from operations, and we will just let those functions take care of themselves. And we already wrote our code in a way that lets them do that. So, yay. Of course, what's going to happen as we try to grow a tree, for every single tip that we have grown, there are now 3 tips here. Each of those tips is going to lead to another call to grow multi, and each of those is going to call grow from 3 times, and those will also call the helper functions and so on. So this thing is going to grow in a kind of interesting, longer and wider fashion at the same time. And there are 2 different types of iteration that are going on when we do that. Let's start with the familiar one. The function that we're about to write, called growmulti, is an iterative process that independently creates 3 new tips from one old one. So if we had one tip that we feed into growmulti, all I want to do is just call grow from 3 times. And this is a kind of iteration that we've encountered before. We have, in fact, done it earlier in our code. So let's have a go at writing the function, this growmulti function, in the fashion that we are already kind of familiar with, and we'll use a for loop for that. So I tab over here, and if I have a look over in my ashtree function, what I've what I've done is I've got an iterative process that I've already bundled into a loop. What I've got is this iterative process that grows the tree, or that grows the segment. Starts at the bottom, iterate 1, iterate 2, iterate 3. That's how that function is operating. Growmulti is going to be the exact same thing, but instead of going up, 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 it's going to go boom. It's going to go boom, boom, boom. So it's going to iterate with the same kind of process, but we're going to go wide instead of going long. But the same kind of loop will work for us. So Let's go back over here into the workers function, the workers script, and define a new function called growmulti. Growmulti. So the growmulti function, we expect to take tips as the argument. So it could just be one tip, and that's how we're going to think about it initially. But in the long run, it can take. We'll hope it will be able to take multiple tips. Okay, so when we did anything with tips before, what we were doing is just using the grow from function. But instead of calling it once there, what I want to do is call it 3 times. So let's do something like this. So I'll go back over here, and let's go back down to the function I'm going to write and go, okay, let's create a loop. So we've got for I, which is just a generic variable that I'm going to use to be our indicator variable. For I in 1 to 3, like I actually don't care about the value of I. All I want to do is just loop over something 3 times. And then what I want to do is go tips is let's go, so I should call this new tip is grow from tips. That will work in one sense of the term, right? What it'll do is it will take the tips as input, it will start iterating. So it'll say I to 1, it calls grow from, creates new tips, goes back up, sets I to 2, creates another new tip, goes back up, does it a 3rd time. But what we're not doing, of course, is we're not succeeding in what we're not doing is we're not storing the result as we go. So we better do this, right? So we'll kind of have something, we'll call it the branches, I guess. The branches is a list, and then what we'll do is we will say that the ith set of branches, so go branches, if you recall from earlier, when we're chucking things into a list, because the lists are arbitrary containers, the double square brackets are what we need to do, and we'll chuck new tips into there. Okay, so we go branches, new tip, new tips. Cool. And then what we're going to do is have this thing now return something to the user. So we'll go return branches is the thing that the user will probably want at the end of this. So let's save it. It is worth taking a second before we even try to run this to work out what our problem is going to be. At the moment, what we've got is tips comes in as a tibble, and then what we're going to do is create a list that has 3 tibbles in it. We've got 1 tibble, and then another tibble, and then another tibble. But really, the thing that we actually want really is probably just 1 tibble, right? What we would like to do is collapse this list of tibbles into just a single tibble. That's something that bind rows can do for us. So we can kind of just go branches equals bind rows, branches, and then we'll get something that should, with any luck, return a tibble. Okay, so I will save that. So now we have a new function that does something that appears to do something that seems very familiar. We've got a loop, and it's just going to grow a bunch of branches inside a loop. So now what we want to do is pretty simple. Back over here in our ash tree process function, all we really want to do is just replace grow from with growmulti. So we go Control S to save. I don't know, I'll click on this to source, and ooh, we have something that looks like a tree. We are making progress. And so since it's been 20 minutes, I'll stop there. Probably forget which keys do what. Let's